Alright guys, today we're going to look at two very special cases for solving linear equations. Cases where we just kind of have to be a little bit careful. Most of the time, when you're solving a linear equation, you simply end up with x equals a number. Unfortunately, that's not going to be the case in either of these. So what I want you to do is quickly try to solve both of these. Pause and then come back, but try to solve both of them. And when you get to a point where you're kind of stuck, just stop, try the other one, and then unpause, and I'll kind of show you what to do with that. Okay, so hopefully what you noticed here is we do have to distribute the 3. Again, just a little annoyance, nothing big or major. When we add 9x to both sides, in an effort to try to get all of our x's onto one side, our variables kind of go away. Because negative 9x and 9x is 0, same as it is on this side, and we get 5 equals 3. Well, we'll come back and try to remedy that in a second. Let's see what happens with this next one. Over here we get 4x plus 12, and over here we get 4x plus 12. We get the exact same thing on both sides. I mean, if you wanted to, you could try to subtract 4x from both sides, and all you'd get is this fun little statement of 12 equals 12. What you're going to find here is that if we look at this top one, 5 equals 3, that's something that's never true. The reason that we get something that's never true, 5 doesn't equal 3, is because this equation is never true. If you tried plugging in a number for x, you would find out that you could plug in as many different numbers as you want. You're never going to get the left side to match the right side. This equation has no solution. So when you get something that doesn't make sense, like 0 equals 2 or 5 equals 17, that's a situation where you have to have no solution. Okay? The other thing that can happen when variables drop out is that you get something that's always true, like 12 equals 12. We could check it here, but I could plug in any number I wanted onto both sides, in for all those different x's there, and I would always get the same thing. A simple thing to try would be x equals 0. Go ahead, try plugging in x equals 0. Pause if you like, or do it quickly in your head and see what you get. What you get when you plug in x equals 0 is you get 12 equals 12. If you plug in 1, you get 16 equals 16. It's just going to be true every single time. This is what we call an identity. An identity is something that's always true. The other thing that you might say if you were trying to actually come up with what x is, you could say that x is all real numbers, meaning that you could plug in anything you wanted for x and that would work out just great. So what I'm going to have you do is that there's really nothing new for you to learn other than if your variables drop out, you're either going to get no solution or identity. So I've got these 3 equations down here for you. What I want you to do is try to solve all 3 of them, figure out if it's identity, no solution, or if it's just a regular old normal answer, x equals something. Okay, pause and then come back when you're ready to check your answers. Alright, welcome back. Let's see what we get. On the first one, I get 4x plus 7 equals 5x minus 6 after I combine my like terms. I'm going to subtract 4x from both sides. Doesn't matter what side you collect all your x's on. Some people are more comfortable with the left. I don't particularly care. I actually get a real answer here, so I get x equals 13. That doesn't really seem to be that big a deal, so hopefully the other two are the more interesting ones then. So here, I need to distribute first. Boy, I made these really obnoxious on you. How nice of me. So I distribute first. Then I combine my like terms. Hopefully you can kind of see where this is going already. I get 2x minus 2 equals 2x minus 2. If I subtract 2x from both sides, I get negative 2 equals negative 2. That's an identity, or x is equal to all real numbers if you prefer. So I'm guessing, based on logic, that this one is probably going to be no solution, but let's just check to be sure. Maybe I was crafty when I was making this one up. I don't really know. So I'm distributing my 4. Then I'm combining my like terms. Then I'm subtracting 2x from both sides. And sure enough, I get 4 equals 6. Well, that doesn't make a lick of sense, so no solution is unfortunately what we end up with there. So nothing really new to learn here other than those two quick things that if your variables drop out, identity or x equals all real numbers, that's the same thing, or no solution are your two big possibilities there. But as far as the solving goes, the solving process didn't change a whole lot. That's it.